Now that we've seen what Edison can do, let's talk about why we should learn more about robotics. So first off, it's fun. It allows for more creative thinking, hands-on activities. You can use programs such as EdScratch or EdPy and test it with Edison. It does create teamwork. You can work with others to find solutions, and most importantly, perseverance. So you don't give up. You always have to keep working until you find the correct answer or ask others for help. There's a lot of trial and error, but it lets you keep working at it. And you get to learn programming while working with robots, so that makes it extra fun. And robots no longer look like this, so they can be different now. So this is what Edison looks like as we saw in the video. Here he is. This is Edison. So what can Edison do? It can dance, detect obstacles. It has a light following sensor, light alarm, drive forward, backwards, left and right, play tunes, drive in shapes, so you can create shapes and have him drive in those shapes, make an alarm, and respond to a clap. So here's the components of Edison. This is the record button, stop button, play button. Here's its light sensors and LEDs. And this right here is the buzzer or the clap detector. What languages work with Edison? There's EdBlock's programming language, EdScratch programming language, and EdPy programming language. For the videos, I used EdPy, and I'll be going through those videos to show you how we made the code for those programs. Here's the code that was used for the clap sensing program. So here we have the use of functions, and then we also have the use of a tune string. So for this program, we had to define our functions, and they start with being able to blink his lights, play tune. He drew a hexagon in the program, a square, and then a triangle, and then he danced with the shimmy and did the twist. For this program, the Edison is using the sound sensor. So it's really sensitive to sound, including claps, but it is also able to detect any loud sound. Or if you can't clap, and let's say you want to use the clap sensor, you can tap the buzzer or the clap sensor on top of Edison, and it'll react the same way as if it had heard a clap. The second program that we used for the video was the light following sensor. So this uses a while true statement and if and else. So while this statement is true, if the light sensor, so this one uses the light sensor, is on the left side of Edison, then Edison will drive towards that direction. Else, he will drive towards the other right side of the light sensor. So this program is comparing the left and right sensors, and it's causing Edison to drive towards the light, whether that be left or right, whichever one side is brighter. So for these two programs, we use the light sensor and the sound sensor. Here's the last part for this video. You get to create your own Edison program. For this program, I would like you to use a flowchart. Here are the symbols for the flowchart. So here we have this oval. This stands for the terminator. So an oval represents a start or end point. Arrow, a line which acts as a connector, showing the relationships between representative shapes. A parallelogram shows input and output. Your rectangle shows the process, and a diamond shows the decision. So here's a sample flowchart. You start, was the clap detected? Yes or no? If yes, then the left LED will turn on, it'll wait. Then the left LED will turn off, and then it'll wait. If you notice, there is no endpoint, and that is because it's a loop, so this program will continue. If there was no clap detected, then it would just go back and wait for that clap to be detected. So you create a flowchart using the symbols. Then it must include either the sound or light sensor. It does not have to be complicated, so whether you don't want to do a clap detected. You can do a light sensor. If the light turns on, it'll beep, then it'll wait, it'll beep again and wait, and you can create a loop that way. So that would be your task. Either the light turns on, it makes a sound, it moves forward, it moves backward, it turns left, it turns right. That would be your action, so your task. And then here's the rubric. 20 points if all the guidelines are met and exceeded. 15 if all requirements are met. 1 requirement was not complete, 10 points, and 5 if more than 1 requirement was not completely met.